Stop whining. I don't care.
Dude, my
No.
haters. He's like it's on fire. It's 20 pages in one night. 20 pages.
No one cares. All right, here we go.
We get it.
Questions on this? How do we feel about basic translations? Good? First page? Wonderful. Page 2. How do we feel about reflections? Basic reflections, not the ones that we were doing that were crazy. Remember 6 was optional. I will tell you the rule on Monday if need be. Everyone shut up so I can hear other people. Does anybody want to see 4 through 6? I know we did a lot in class. The rule for 6 is self-development. Awesome. Let's talk about what we actually learned the other day then. Page 3, 7 through 9. Questions on that? Six? No, we're not doing that. I said 7 through 9. We moved on.
Scammers get scammed.
7 through 9, yes or no? Okay. 8? Why do I have to ask the question like 7 times before someone will go, hey, how about 8?
Why not?
Why can't we just answer the first time instead of being dummies? No, every single one of you is a moron. All right. That's A going to the center of rotation, which is our origin. A is 4. We're flipping 180. As we go 180, we're going to go 90 this way and then 90 that way. So it's going to be the same length here, and that's where A prime ends up. Same thing for B. It's just going to be 8 in length. Flip this way. There's B prime. And then C prime is going to share the same blue leg as A and B. It's just going to dip down for 2. When we rotate that, it's going to be going from vertical to horizontal and then horizontal to vertical after we do 180, right? It's going to be vertical again, but instead of pointing downwards, it's going to be pointing upwards. So C prime is going to be there, and there's our new triangle. A, B, and C. Our coordinates, Danny, shut up. I know, but like you're being very loud and you're only talking to one person and everybody else has to hear it, which is just getting annoying. C is negative 6, negative 2. A prime is negative 4, 0. B is negative 8, 0. And 6 is negative, C prime is negative 6, positive 2. So our rule here is going to be what? Negative x, negative y, is that what you said? So if we go negative x, negative y, works. Now, the key one to look at is C. When we have zeros, it's kind of hard to tell, right? Because if you negate 0, it stays 0, right? If you multiply 0 by a number, it stays 0, right? There's not a lot of good ways you can tell what's going on with zeros. So it's best to look at where we have some actual numbers, right? We keep everything the same. We just change the sign. So here is our rule, and that's it. So that's the rule for 180-degree rotation. The question is why? Why is that the rule for 180-degree rotation? Can anybody explain it? Zayden. That's a really good explanation. All right, so quadrant 1, the coordinates here are both pluses, right? So we have like a positive 3, positive 4, right? Any dot that's in here is going to be double positive, right? If we go here, our quadrant is negative positive, negative something, positive something, right? Down here is double negative, and then over here is positive negative. So if we start a point here, and we flip it 180, we're going to go 90 degrees to here and 90 degrees to there. So it's going to end up here. And notice the difference between these two quadrants, right? Both the signs are changed. If I was to start a point here, it would end up here after going 180. So both again, both the signs are changed. This also makes sense if we flip something 90, right? If I start here and flip 90, notice that only one of the signs change. And we had that when we did number 7 above it. So if you think about the quadrant and where it's going to end up based around the origin, you can kind of predict what the rule is going to be, right? Which is going to change and what's going on there. Back for number 7, I'm going to rotate this really quickly without doing the L's. We had this going on, 3, 3, so 3, 3. That's where C prime is. This is 6, 3, so it's 6, 3 here. B prime, 6, 6, so 6, 6. So there was, oops, I put A prime too far over. All right, so not that one. So there's our rotation, right? What was the rule for number 7? What happened? Yep. So one of our signs changed, which makes sense. You can see that happening here, right? That's going to happen with those coordinates. X and Y change spots. Why did X and Y change spots? Does anybody know how to explain that? I'll give you a hint. If you look at B, the L for B is this. And then B prime gets this. Can anybody explain why X and Y change spots? I'm going to give him a couple seconds, Aiden, before you answer, just in case you're right. Xavier, what are you saying?
What was the question?
Why do X and Y change spots here? We know why they change signs, right? Because if you look, we have this going on, right? That's always going to happen when we do a 90-degree rotation. It's going to change the quadrant, right? Yeah.
When you counterclockwise, it has a 90-degree angle.
Say the last part again.
It's like a 90-degree angle counterclockwise, so it go down. And it's looking like that or something.
You're on the right track. I think you have the right idea, but you haven't explained it to the point where I know that you know that, so I'm going to keep going with more ideas. But you're definitely on the right track. Not quite. Coincidence. You found a coincidence, not the pattern. Yeah.
Wait, yes, the pattern?
I'm asking why do we switch the X and the Y's here? Why is that the rule? Why does that make sense?
The quadrant signs are changed.
That explains the negative,
Yeah.
right? Because one of our signs change.
Oh,
But
why
it
they
does.
switch.
Why do they switch, right? Why do the X and Y change spots? You want to try again?
Yeah, because the X basically becomes the Y.
What do you mean?
Like, because how it moves, it goes from like.
He's absolutely right. You've got it. You've got it. Yeah, you've got it. I don't think anybody knows what you mean yet, though. I know what you mean.
Alright, thank you.
Are you seeing it? Coda?
I was trying to say it earlier.
Blue line,
Yeah.
like rotates down.
Yeah. What about the blue line?
It goes across the y-axis instead of the x-axis.
Okay, cool. So we're getting there. We're starting to get it. Here's how I'm going to explain it, and hopefully it makes sense to makes sense to you guys. Check out the blue line. The blue line is horizontal. It's 6, right? So our x is -6, and our y is +3. Now notice what happens. When the blue line moves, it's no longer an x value, right? It's vertical, and so it's a y value that's -6. The signs stay the same. The numbers change spots, though, because that's an x value. It's going to left, right? X has to do with the horizontal. But when it becomes vertical, now it's talking about the y value of this guy's coordinate. Here was a 3, and it was up and down, so that's a y value. When we switch it, it's going to be an x value, and notice the sign changes. So our signs change between here and here, and they stay the same there. This was the x value. Now it's the y value because it's vertical. So the x and y change spots. Notice that when the x and y change spots, the x changes with the y, and it doesn't change its sign. The x switches for the y and doesn't change its sign. Here, it was vertical, so it was a y value, but now it's an x value because it's horizontal, and it does change its sign. So what was once the y is now in place of the x. with the sign changed. That's what's going on there. If we go down to number 9, here's C. We're rotating clockwise, so we're going to end up over here. 7 and 3. Notice that was what once was our x value has now become our y value here, right? It's up and down now. And what once was our y value has now become our x value. Well, y here was 3, positive. It's now still positive over here. So the x and the y, when it switches, doesn't change anything. So what once was our y value has now become an x value and kept the same sign. What once was our x value has now become a y value. What's this number down here? How long is that? The blue line. Seven, and it's negative, right? But when we flip it, it becomes a positive 7. So x switches to y. So that x that was there before is now a y value, and it changes its sign. So that's the rule. Are you getting about 25% of this? Put it away, because I guarantee you don't understand this stuff. You might be able to do the rotations, but you have no idea what I'm talking about here, and this is like really interesting stuff. You should put it away as well. It's not working out so well for you.
Put what away?
Okay?
You're checking my answer.
No, your answers are great, but I think the understanding that's here, you're completely missing. Danny, shut up. You're not that funny. You were for like 2 weeks. And now you're just wasting everybody's time.
And our oxygen.
Right. I just want you to get funnier or shut up. That's the option. And I'm not mad. It's just like, no, shut up and listen. Shut up and listen. Shut up and listen. Okay? I know. You're trying to recover this because, like, your act is bombing, right? You're on stage and the crowd is booing you because they're annoyed and it's wasting their time and they're like, bring on the next entertainment. Literally anything, right?
$20 on this show and it sucks.
Danny, I'm trying to have a heart-to-heart with you. I'm being serious, okay? I don't want you to turn into a comedian and go that route when you suck at it, okay? You need to find another stick.
I thought like Kevin Hart.
No, you're just small. Questions on this? Cool. I got some for you.
Dude! Already saved. Turn it off at least.
No, I'm gonna keep it on. I'm gonna turn on your flashlight and I'm gonna learn the battery out. And I'm gonna give it to you at the end of the day.
And then we'll punch your phone easy and you.
No one missed either. I spent all study hall and all my energy for it.
Dude! I'm sick of it.
Taking the phone does nothing for me, but it does great stuff for the rest of your team. They will be thanking me. Yes. These are all extra thick. I apologize. I didn't print them back to back. They're also extra thick because I gave you the answer key. Which I did on purpose, yes.
Ms. Leader should do that.
That is illegal. No more.
Need my phone.
Your explanation wasn't concise. It was all
Does anybody know which of the following blood vessels that deliver number 8, less than 14.2?
Wait, what is it?
Less than 14.2.
yes. I know what you mean. I think after we
Page
do
135.
some advanced rotations, you'll start to see what's going on a little bit. You what?
Wait, which one number?
I know, right? Good hit last night. Yeah, I shouldn't have left his feet. Yeah,
Eight.
adorable.
Yeah.
They take away.
All right, the plan is I'm going to do 2 rotations with you. The rest of the packet will be yours. Then we're going to look at the answer key and we're going to analyze it a bit.
Veins take away and go to your muscles. Yeah, they do.
I thought those delivered.
No, veins take away from your heart and to your muscles, right?
No.
Yes.
Are we talking about the direction of blood flow?
Yes.
Yeah.
Yes. I'm right.
Boom.
I'm so sorry. Zane, you're just so smart. Let's see. When in doubt, pick C. Dang, that
What's
was
up?
not funny.
What? We're getting serious.
Danny, I want to finish this packet.
What you're complaining is just do the work you have.
Small child cries in class. 2019. Great video.
Small child has lost.
All right.
They're probably wrong.
All right. So, because no one cares about that, -1, -5 is our center of rotation. So we're changing the center of rotation today. It's not just going to be the origin. This is going to make things weird. 1, 2, 3, 4, 5.
But I only have like 5 more pages left.
So that is our new center of rotation. We can call that R. Everything is going to stem from there. So when we do, so these have to last me to the end of the year, and I have very little money because I'm too busy spending it on you guys, like things like this and markers that you guys use in class. So what I want you to do is stop doing that because it's a waste of everyone's time and my money. Sit down.
What kind of markers? Expo markers? Okay.
So when we flip these points, we need to call them something. So let's call this point right here A, and call this one B, and this one C. Now, we know the answer. It's on the back. The point is not the answer. The point is to give you plenty of practice because this will be on your quiz. And I want you to feel comfortable doing rotations. Because eventually, we're going to get into the rule for this stuff, and it's going to blow your frickin' minds, okay? So, instead of drawing our L to the origin, we're going to draw it to R. And we're going to do a 90 degrees clockwise rotation, which, of course, is in this direction, the way a clock goes. Let me zoom in a little bit more for you. All right, so when we do this, we've got a horizontal line that's pointing to the left, going from our center of rotation. And we do 90 degree, it's going to be vertical, pointing upwards. Everybody cool with that? All right. So now A prime is going to be here. Everybody cool with A to A prime? Yeah? Awesome. So now we're going to go from R to B. Notice they share the same blue leg. So it's going to be somewhere on here for our blue leg, just a little bit longer. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So up to here. Same blue leg. And then we're going to extend out this red leg that is also 5. Now what direction is the red leg going to go? If we turn it 90 degrees, it's going to be horizontal, but is it going to go to the right or the left?
To the right.
To the right, to the right, to the right. 1, 2, 3, 4, 5. So now we have B prime. How do we feel so far about doing this? If you didn't see it initially, do you see it now?
That's kind of hard with just like one color pen.
Right, it is. I would encourage you to get more colors. That's why I let you guys borrow. Unfortunately, I don't have a lot of pens right now. I just have a lot of markers. I just got a paycheck today, so I'll buy some more pens. That way you guys can share. No. So, oh my God, Danny, stop wasting our time, please. So, I know, but no one cares.
Your wants don't matter, so quit your whining.
Xavier, please stop. So, we're going to go from R to C now. So this is going to be our L. When we rotate that down, it's going to point downwards. Same length. 1, 2, 3, 4, 5, 6. And then C has the red part of C has a length of 5. Is it going to point to the right or the left when we rotate it? When we rotate this L right here, how's it going to point? It's going to point to the right. So here's C prime. And here is our new triangle. Be sure to connect the prime points, not the originals. I saw someone make that mistake earlier today. That's a common mistake. So there is our triangle, and it might help when you're confident that that's the answer to color it in so you can see what's going on, right? So there it is. Let me zoom out a little bit. So our triangle that was here, right, is now rotated there. That's a 90 degrees clockwise rotation. How do we feel about that idea? We feel like we know how to go about rotating something. The tricky part is probably just figuring out which way they point, right?
Yeah.
Okay, and that'll come with practice. All right, so again, they give us another center of rotation for the second one, 5, -5. That's going to change things up a bit. It's not going to be crazy for actually doing the rotation, but finding the rule, which is what we're later going to do and explore a bit, it's not going to be on next week's quiz, but it will be soon. That'll be the weird part. So 5, -5 is what we're working with. 1, 2, 3, 4, 5, down 5, 3, 4, 5. So there's our center of rotation. So everything is stemming from that. Let's label our points. I'm going to label this one A, this one B, and this one C. Obviously, you could label them whatever you want, but if you want to follow along with me, I think it would be helpful to keep it the same. Try that. Okay, so let's flip A first. And by flip, I mean rotate. So we've got that length. And if you want to rotate each bit at a time instead of drawing your L all together and then rotating it all at once, I think that might be helpful. So let's rotate this 1, 2, 3, 4, 5, 6. If we rotate 180 degrees, notice they don't say whether we need to do clockwise or counterclockwise because you're going to end up in the same spot either way. So I'm going to go 90 degrees this way and then 90 degrees again. So again, 90 degrees once gets me vertical, right? 90 degrees again get me horizontal. So it's going to be pointing in the opposite direction, the same distance. 1, 2, 3, 4, 5, 6. And now let's get our red part. Tiny little red part going to A, right? And so it's pointing down. We're going to go from vertical to horizontal to vertical again. If it was pointing down, it's now going to be pointing, what? Up. Again, it might help to visualize that. Where did my... So if you have a line that's pointing downward, right? And if you turn it 180, here's 90 again, it's now going to be pointing upwards. And now that you know it's pointing upwards, you can just go to this and not make the mistake that I just did and have it point upwards. A prime. Better? We're going to do the same thing for C and B. So B is going to share the same blue leg with A. It's just going to cut early, right? So it's going to be 4 in length for the blue part. And then it's going to cut early. If it's pointing up originally and we flip 180, what direction is it going to point now? It's going to go down, right? I believe that is 1, 2, 3, 4, 5, 6, 7, 8, 9 in length. So it's going to go 9 down. And there's B prime. How do we feel about that? Again, the idea is that we start vertical, we turn 90, we turn 90 again. It's going to be pointing downwards now. Notice that C is going to share the same blue leg as well. It's going to be the full length. And then it's going to go, instead of up, it's going to point which direction? Down again, right? The idea we point up, we turn 90 again, now we're pointing down. So it's going to go down, and I believe that amount is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's C prime. You connect all your dots. There's the new triangle. I'm sorry that you can see that. And there we are. How do you feel?
Is that clock wrong?
I don't know.
Well, I should tell the time, but.
All right, raise your hand if you think Danny's funny.
No, I want my phone back.
That's it. I know, but like, do you sound how not funny you are, and also like what a waste of time you are, and how annoying it is? Like, do you understand why that's annoying, or do you need me to explain it? Okay. So if you're gonna do that, how about you don't? Okay. Are you annoyed by me stopping class and having to tell you how annoying you are? Okay, so pretend I'm not saying that, but instead I'm saying, I just want my phone back. And now you understand me perfectly. Did you learn something today? Because I just got done teaching. Well, then there's no hope. So let's look at the next page. Look, the answers are right. Fantastic. Now we said earlier that our 180 degree rotation results in negating both the x and the y, right? Xavier mentioned that. So when we flip 180, it changes quadrants, which changes, it changes two quadrants, right? It goes 2 quadrants over. It's going to change both signs. Now, here's the deal. When you look at the second one that we just did, here's B. What quadrant is B in? Quadrant 1, 2, 3, or 4? What quadrant is B in? Starts at 1, right? And 1 is double positive. So we're starting out double positive. Well, you'd think if we negate both the x and the y, then B is going to end up down here. But it doesn't. It ends up over here. Again, look over here. When we did this 180 degree flip, C went up to this quadrant. That makes sense. 180 degree rotation, right? We change both signs. But when we have the center here, we would expect B to be over here, but it ends up down here. Why is that? I mean, obviously it has to do with the center of rotation being different. But how do we make sense of that? Because now B is positive negative. Yeah.
When we move the point of rotation, we are also moving the relative origin. So if we do that, we would have to draw another set of quadrants based on that origin. And when they overlap, that's the
This man should be in senior classes.
Nailed it.
He should be in college.
Great observation. Again, it's not that he calculated stuff and did all these numbers in his head. He just saw what was going on. So he's got great vision. So let's give you guys some vision as well. So imagine that our axes were actually centered here. Well, what quadrant is B in then? Using the pink axes. What quadrant is that? Quadrant number 2. Our coordinate would then be negative positive, right? And then when we flip down here, we're in quadrant 4, which is positive negative. So if we're able to visually recenter our origin to our new point of rotation, it does make sense. It does work that way. Now the question is, how do we take our origin and recenter it to this? Because it's not going to be just flip the signs now. There's going to be another action required to recenter this. How are we going to move it from there to there? Just in case you're right, I want to wait. I want them to see it. Take some time looking at it. How do we recenter something by moving it? Not rotate. We're not going to rotate that point to here. We're going to slide it. What's a slide? Is it up there still? No, it's not. What is a slide? What's the fancy word for a slide? Como se dice? Como se dice means how do I say that? It's asking for the what? Not for the answer. Como se dice is how do you say it? It's asking for the translation. A translation is a slide. So we're going to translate something. How do we translate something by a vector? What do? Do we multiply? Do we divide? What do we do to the coordinates? Yeah. Add and subtract, exactly. So there's going to be addition and subtraction going on here, and then we're going to apply our rotation. Now here's the deal. When we slide this origin and then apply our rotation, it's going to give us the coordinates as if that was the origin, right? Which is great, but we don't want it that way. We want it as if that's the origin because, hey, it actually is, right? So here's what we're going to have to do. This is brilliant. Well done, guys. So we're going to slide this to match up to this rotation. We're going to do our rotation, change the signs, right? And then we're going to slide it back.
Makes sense.
So we're going to slide it, rotate it, and then slide it back so we get the correct coordinates based on this origin. If I've got you at about 25% or 50%, that's great. If you're not quite there yet, that's fine. This is your first day of dealing with it. This will not be on the quiz, but I want to talk about it, okay? Your job over the weekend until it's due on Tuesday, so you can wait till Monday if you want to do this. Technically no homework on the weekends, right? Is to do the rest of these rotations, which I already gave you the freaking answers to, okay? So practice that. It's for your health. Let's talk. Sorry, I know, right? My bad. That was funny. Let's talk about what happened here, okay? Let's take point B. Point B's actual coordinates based on this center are 2, 1, 2, 3, 4, right? So here's B at 2, 4. Cool. B prime, which I'm going to do a long arrow because it's going to take a bunch of steps to actually get there. In fact, let's call it B double prime because we're going to make a pit stop on the way. Its coordinates, we found out, were here, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9 over, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 down. So 9 over and 14 down. Did I count those correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 down. Okay, cool. I think I got those coordinates correct. 2, 4, 2, 4, 1, 2, 3, 4. Yeah. Oh, hold on. I think I screwed it up. Isn't it 1, 4? Isn't B 1, 4? Thank you, Jess. All right. Okay. So obviously we can't just change the signs and get this, right? That's not how it's going to work. Our center of dilation is off. So we need to factor that in. What is our center of dilation? What do they tell us it is? 5, -5. Ready for this? We're going to take our origin and slide it here. Now, when we slide our origin to here, we're sliding everything by that vector. Our vector to get from there to there. Wait, hold on. Do I want to go from there to there or there to there? Direction matters. I think it's that. Okay. So to slide from here to here, that vector, we went over 1, 2, 3, 4, 5, and down 5, right? So we went +5, -5. That's the vector we're sliding by. Now when we do that, it shifts everything. So point B is also going to slide 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B is going to slide to here. Every point is going to have that happen to it, okay? I'm just illustrating with just B. Everything slides here now, right? And that gives B a new coordinate. So we're going to apply that vector to B. So let's do that. B prime, not B double prime, that's going to be where we end up at the end, right? Is going to be add 5 and -5. When we do that, we get 6, -1. So what we've done so far is we've slid, right? That's our slide to move everything from here to here. So now we've got our new origin, right? Now we need to apply our rotation. It's a 180-degree rotation. What's the rule for a 180-degree rotation? Change both signs, right? So let's do that. Now we're going to apply this. B prime 1.2 is going to be this, +1. So this is our rotation by 180. So we slid it, and we got here. We applied our rotation and got that. Now we need to unslide it. So we slid by +5, -5. How do we undo a +5 and then a -5? -5, +5. So now we're going to slide it by this vector. How do we apply that? -6 becomes what? -11. And 1 becomes 6. So the question is, did we do this right? Because B prime is what we wanted. What's the coordinates of B prime? 9, negative 14. Ah, man, what did we screw up? Makes sense. We slid it, we rotated it, we slid it back. Why is it wrong? And that's the question I have for you today. Here's what we did. We slid everything to our new center, right? We rotated it, and then we slid it back. Why is it wrong? Zayden, what do you think?
I don't think that we needed to slide B along with the origin.
What do you mean?
I think that when we slid the origin to 5, negative 5, that B should have stayed 1, 4, and then rotated it and then slid it back. So then when we rotated it all, it would actually end up in the 4th quadrant.
So using your way, you're saying don't add 5 minus 5. Just flip it to start out, right? So we get this. So we rotated it because we changed the signs, right? And then you're saying now slide it, and we'll end up here? Not quite, right? No, we do need to slide and slide it back. When I slid it this way. I did plus 5 minus 5, right? What if instead of bringing the origin to this, we brought that to the origin? How would that change it? Instead of bringing this to this, plus 5 minus 5, we brought this to that. It'd go minus 5 plus 5, so our vector would be different. Let's try that. We start with B. B is 1, 4. We're going to slide it by this vector this time. We're going to go the opposite way. Where do we end up? Apply this vector. Negative 4, positive 9. Now we're going to rotate by 180. How do we do a rotation by 180? What's the rule? Flip the signs, right? And then we're going to slide back, right? Well, we slid by negative 5, 5 to start out. If we slide back, we want to undo that. How do we undo a minus 5? Plus 5. How do we undo a plus 5? Minus 5. Add 5. Subtract 5. All right, okay, all right, okay, all right. So, let's talk concepts. First of all, what did I do? Second of all, why did that make a difference? Okay, so first off, did we bring the origin to our center or our center to our origin? What did we do? We brought the center to the origin. So we shifted everything this way. Okay. Then we rotated it, and then we slid it back. So we moved it back down here. I'm going to say it again. We slid from here to here. That's why we did minus 5 plus 5. Is everybody cool with that idea? You smell what I'm stepping in. We took the origin, our center and moved it to the origin. We did that by going minus 5 plus 5. That's our vector, right? We slid it, translation. Then we rotated, changed both the signs. Then we slid it back. And the way we slide it back is plus 5 minus 5. Is everybody cool with that concept? Now the question is, why does taking one to the other versus the other to the one matter? Why? Why should it matter?
Don't ask me.
We weren't supposed to get this far today, but you guys did a really good job. Coda.
Because you're changing the starting triangle point, so you're basically changing the whole.
You're not wrong, but you're not saying anything that leads us somewhere. let me try to put it into words that because you maybe didn't catch it the first time, right? Well done. So if we move R to here, which is the right way, then it centers it at 0, 0, and now everything's like it was supposed to be, right? That's how we used to do it. That's how we did it the day before, and everything worked out nicely, right? You just change the signs, everything's great. But if we move this to this, now we've shifted everything over, and so now it's going to be weirder, right? We just moved everything further to the right, because not only did we move our origin, but we kind of technically moved this, which makes it even worse. Moves it further away from our goal. When we flip it, when we do the rotation, I shouldn't say flip. Flip is reflection. When we rotate it, right, we need an origin of 0, 0. So we're going to move this guy to 0, 0. We're going to move him to where it was nice yesterday, right? If we move this to him, we're just compounding the problem. Now, maybe you don't understand exactly what I'm saying. Maybe you've got like 20% of that. That's great. That's fine. But well done. That's absolutely right. We need to move him to the origin. That way everything's kosher. It's everything like it was yesterday, right? Everything's at 0, 0. Everything moves back. If we move this guy, we're just moving everything further away, right? Maybe you've got it. If not, that's fine. We have time. It's not going to be on the quiz next week. But the idea is we need to move our center of rotation back to the origin. We got to take it back to the beginning. Back to the beginning. Cool. That's rad. Let's try this one. Our center of rotation is -5, -3. 1, 2, 3, 4, 5, down 3. To make this kosher, we got to take this guy and take him back to the origin. What is that vector that's going to take him back to the origin? What is the vector? Let me zoom in so you can see it. What's the vector that's going to take this guy back to the origin? 1, 2, 3, 4, 5 in the x direction, positive, and then up 3. So we're going to slide all of our original points by 5, 3. Then we're going to flip it using our rule, 90-degree counterclockwise. That's going to be a weird rule, right? We have to switch the x and the y's, negate one of them. We'll think about that in a second, okay? And then we're going to slide them back. Let's take this point, call it A. A's coordinates are -1, 2, 3, 4, 5 to the left, and 1 down. So there's A. Cool. We're going to slide it by this vector, 5, 3. So we're going to apply 5, 3 to it. I'll wait for you guys to catch up, and then we're just going to go into the algebra, okay? All right? Rotations. Boring. Rotation's about an arbitrary point. Oh my God! All right? Juicy. Juicy. There's something here. New way of thinking. All right, so now after we do that, we've got our new point. We add 5, we get 0. We add 3, we get 2. So A has moved from here to here, which makes sense. Same vector, right? We haven't rotated it yet. Now we're going to rotate it. How do we rotate 90 degrees counterclockwise? What's the rule for that? Look up here. Pick a spot. I'll pick this one because it's plus plus. Counterclockwise. Which direction are we going? Are we going this way or are we going this way? Counterclockwise, opposite way of the clock. So we're going to this quadrant, 90 degrees, right? It's going to be over here now. This quadrant has negative, positive. So this guy's going to change, right? Now the question is, when we do this, we know the x and y have to flip, right? We know that because what once was an x is now going to be a y. Sorry, this flip is really bad. It's going to be like here. This flips to that. So these guys switch. Which one's going to change its sign? This one. That's the rule. Let's apply it. Again, if you're getting 25% of this and you're like, I don't follow how he did that, that's okay. The how isn't important right now. Okay? Hang on your butts. We're going to flip them. And we're going to negate this one. For those of you following along at home, that means A prime has moved back to here. We rotated it 90 degrees counterclockwise. Do you see it? Now we got to slide it back. So we're going to undo this vector. Our vector was 5, 3. We're going to undo it by doing -5, -3. Subtract 5. Subtract 3. -7, -3. -7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. I would highly encourage you not to be writing this down. There's where it ends up. -7, -3. Let's check our answer key. -7, -3. Oh, you didn't see it. Okay. -7, -3.
Wow.
Where are your dots now? See, I miss doing it on the board, because then you can slam the marker down. It's way more exciting. Get paint all over the floor. Right? Sitting here is boring, man. See you later. What? Yeah, you can have it back. Later. I want to make the rest of your day miserable.
That's where I found my desk.